Dear students, in this session, we'll learn about isomers, a part of isomers in that structural isomers, not stereoisomers, only structural isomers. We have to know what is isomer, which are the types of isomers. Isomers, two or more compounds having same molecular formula but different physical and chemical properties are called isomers. This phenomena is called isomerism. It is further divided into the different types. Isomers means the compounds will be having same molecular formula. Molecular formula will be same, but different physical and chemical properties. Okay, the plenty of the compound will be having same molecular formula but different structural formula. Example, you can notice that the compound CH3, CH2, CH2, CH3. What is the name of this compound? 1, 2, 3, 4. Single bond. That is butane. Similarly, how many carbons are here? So, which will be having 1, 2, 3, 4. C4. And hydrogen 3 plus 3, 6 plus 4, 10. C4H10. Right? So, you will write another compound, that is CH3. Next, CH3 above, and next right side CH3, and the name of compound is 1, 2, 3. From this side or this side, we'll be getting the lowest carbon. So second carbon consists methyl group, that is 2-methyl. And what about the number of carbon? 3 carbon and single bond, propane. Propane. 2-methyl propane. So how many number of carbon atom? 1, 2, 3, 4. Okay, and how many hydrogen? 3, 3, 3. 3 plus 3 plus 3, 9 plus 1, 10. So look at this. Butane and 2-methyl propane will be having same molecular formula, but their both physical and chemical properties are different. This is a single example, first example. Okay, so out of the butane and 2-methyl propane, there will be huge difference between physical and chemical property. But what will be having? These compounds will be having same molecular formula. But different structural formula, different structure, different position, different functional group. Based on that, we separated, means we should be having same molecular formula, but they differ in their physical and chemical properties, are called isomers. This isomers majorly divided into two types. Isomers are divided into two types. One is structural isomers, another is stereoisomers. Structural isomers and the stereoisomers. So we'll be studying about only structural isomers, not in stereoisomers. Stereo is the spatial arrangement. Okay, structure based on the structural different. Okay, we'll be studying in detail about structural isomers. For the stereoisomers, the compound will be having, means different the spatial arrangement. Example, this any one of the compound. Example, H hydrogen will be one compound, right? Left side will be OH group. This can be exchanged in another compound and a carbon and carbon. This side is OH and this side is H. So this may happen in the spatial arrangement. That is what we call as stereoisomers. So this we'll discuss later. Okay, so in this session we'll discuss about isomers, the part of isomer, that is structural isomers. Structural isomers, what are isomers? Compounds having same molecular formula but different physical and chemical properties are called isomers. Clear? Next, what are the types of isomers? The types of isomers are isomers divided into structural isomer and stereoisomers. Isomerism is a phenomena. Isomerism is a process or phenomena. In this structural isomerism, this phenomena divided into four major classes. First one is chain isomerism, position isomerism, functional group isomerism, and metamerism. Okay, so isomerism divided into two types: structural isomerism, stereoisomerism. Structural isomers are divided into four types: chain isomers, positional isomers, functional group isomers, and metamerism. Are you getting? Stereoisomerism divided into two types: geometrical isomerism and optical isomerism. So we'll be studying part of isomerism only this structural isomerism. Okay, so we'll see in detail what are the meaning of the structural, what is the meaning of structural isomerism, and what are these chain, position, function, and metamerism. We know that isomers, iso means same, mers means will be having same molecular formula. Structural isomers, the molecular formula is same but its structure is different. Based on structure means compound, two or more compounds having same molecular formula but different structures, are called structural isomers. Structural isomers are divided, or what is structural isomers? Compound, two or more compounds will be having same molecular formula but different structural formula. Structural arrangement is different. That is called structural isomers. And we'll see in detail with an example for each. Okay. And next, first one, structural isomerism. Compounds will have same molecular formula, but different structures are called structural isomers. The sum of the typical examples of different type of structural isomers. In structural isomers, first one, chain isomerism. Chain isomerism. Name itself indicates two organic compound. In that organic compound will be having same molecular formula. If they'll be having same molecular formula, but carbon skeleton arrangement, carbon skeleton arrangement is different. Both are the C carbon, C4 and C4. This C4 is same, that is normal. This will be changes. This carbon can occupy this position. So the chain will be different, but will be having same molecular formula. So chain isomers are the compound, two or more organic compound will be having same molecular formula but different carbon skeleton, different chain or different arrangement of carbon atoms. Okay, that's in branching or in chain. That is called chain isomers. This phenomena is called chain isomerism. Okay, are you getting? So same molecular formula, different carbon skeleton. So we'll see that earlier I said one example. Okay, between butane and 2-methyl propane. Between butane and 2-methyl propane, or between N-pentane and isopentane and neopentane. So look here, in the case 1, 2, 3, 4. I said earlier 4 carbon, C4H10, and here also C4H10. So same molecular formula, but carbon skeleton arrangement is different. And look at this. Now we'll see this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Carbon straight chain. Carbon number 5, that is pentane. That is also we call as N-pentane, normal pentane. Okay, this is normal name N-pentane because as pentane itself is also IUPAC nomenclature. So this compound from this side or this side needs to get lowest number. No, one substituent group needs to get lowest number. 1, 2, 3, 4. So number of carbon atoms are 4. Root word is but. Carbon carbon single bond butane. Okay. If any other functional group, E is replaced with the suffix. Okay. Now the substituent group, it is in the primary suffix. So substituent group in second carbon methyl, that is 2-methyl butane. 2-methyl butane. In the carbon 4 carbon in straight chain, one is in branch. Okay. That is also how many carbon? C5. And here C5. And number of hydrogen atoms 3 plus 3. 6 plus 4, 10 plus 2, 12, C5H12. Okay, similarly, here 3 plus 3 plus 3, 9, 10, 11, 12, C5H12. Similarly, neopentane. For the neopentane, you can give name from 1, 2, 3 or 1, 2, 3. However, you are giving number. If how you are give number, that carbon substituent group should be get the lowest number from this side or this side, whatever it may be. 1, 2, 3. Okay, second carbon consists the 2 substituent group of the methyl. So long chain, parent chain is 3 carbon, that is prop, PROP, carbon carbon single bond, ane, propane. And the second carbon will be having 2 substituent group. Second carbon will be having 2 substituent means number. You need to write the number 2, 2, right? 2, 2. How many methyl groups are there? 2 methyl groups. Dimethyl. 2, 2, dimethyl propane. This also we called as neopentane. Also will be having 3 plus 2, 5 carbon. 3 plus 3 plus 3. Okay, so 12 hydrogen, that is C5H12. C5H12 will be having same molecular formula, but carbon skeleton arrangement is different. Carbon skeleton arrangement is different. These are we call as chain isomers. This phenomena is called chain isomerism. Compound will be having same molecular formula but different carbon skeleton. Okay, are you getting? Okay, next next one, position isomerism. Name itself, earlier it will be indicating the chain. Now it is indicating position. When two or more organic compounds differ in their position of substituent atom. The substituent position, functional group, substituent position is nothing but the functional group on the carbon skeleton. They are called the position isomers. Two or more organic compounds will be having same molecular formula but different in the position of substituent or different in the position of the functional group. Then those are we call as positional isomers. This phenomena is known as positional isomerism. Okay, so you can see the compound name. Okay, 1, 2, 3. 1, 2, 3. So normally what they given is IUPAC name itself. Okay, 1, 2, 3. Carbon number 3, prop. Okay, ANE, propane, right? PROPANE. E is replaced with the suffix is ketone, ONE suffix, that is what? Propanone. Propanone, what the given name, right? Next, 1, 2, 3, it's wrong. From this side, 1, 2, 3 is correct because we'll be getting the lowest number. Okay, 1, if you're not writing, that is 1 itself, the first carbon, first itself. 1 all you can write or directly. Propane, 1 all, 1 on you can write instead of that propanone. Similarly, 1, 2, 3, this side, 1, 2, 3. So in that carbon number 3, ANE, carbon carbon single bond propane, and the E is replaced by with the suffix or the functional group C double bond CHO, C double bond OH. CHO is a functional group of aldehyde. Aldehyde having a suffix al, that is propanol. Propanone is different. This is ketone. This is aldehyde. Okay, just changing the position of the substituent group, then there'll be huge difference between the physical and chemical property. Okay, these are we call as positional isomerism. Positional isomerism, when two or more compounds differ in their position of substituent atom or the functional group, are called positional isomerism. So we'll see one more example. Okay, so here one chloropropane and two chloropropane, one chloropropane and two chloropropane. Here 1, 2, 3 should not be given from this side because chlorine will get maximum number. So lowest number from this side 1, 2, 3. So 1 chloro, 3 carbon, propane, 1 chloropropane. Here 1, 2, 3. If you want, you can count the number of hydrogen and carbon or the substituent group. That should be same. That will be same. Okay. Next up 1, 2, 3 from this side 1, 2, 3. Then you'll be getting the second carbon itself getting the substituent group. So you can name in either the side, no problem. So second carbon consists chlorine. So that is halogen will be add prefix as halo primary prefix. 2 chloro, second carbon consists 2 chloro, carbon number 3, propane, 2 chloropropane. So difference between them, same atomic number, same molecular formula, but differ in their position of the substituent group or functional group, chlorine. And you can notice here, 1 propanol and 2 propanol. 1 propanol for the first carbon, OH group attaches to this, okay, and same molecular formula. And here 2 propanol will be having the second carbon consisting the 2 OH group. Okay, so second carbon consists a single OH group. So we'll be having same molecular formula, differ in their substituent group. Here also 2 butene and 1 butene. Butene, carbon-carbon double bond. Butene, 1, 2, 3, 4. 1, 2, 3, 4 from this side. Okay, numbering should be from this side. 2-ene, carbon-carbon double bond. So second position will be having double bond. No, root word, parent chain is but. Carbon-carbon single bond ene. Where in which carbon it is? In second carbon. So 2-butene. The double bond. Okay, double bond present in this side. First carbon 1, 2, 3, 4. Same butane. So first carbon consists of double bond, that is butene, but-1-ene or 1-butene. This also can be written as but-1-ene or 1-butene. Both are same. So differ in their double bond is also considered as a substituent group or functional group. Chloride, substituent group or functional group. OH is a substituent group or functional group. CHO and C double bond O are the substituent group or functional groups. Are you getting? So compounds will be having, two or more organic compounds will be having different position of the substituent group. Those are we called as positional isomers. Okay, second one. Next, third one. Third one is functional isomerism. Functional isomerism, two or more compounds having same molecular formula but different functional group. Different functional group. Okay, two or more compounds having same molecular formula, different functional group. What the attached same molecular formula? Functional group we need to count, check, that will be different. And these groups are called functional isomerism. So chain isomerism, carbon skeleton is different. Okay. Next, substituent group. Substituent group. Second one. Okay. And second one, position isomers. Position, substituent position will be different. Third one, functional isomer. Functional group will be different, but will be having same molecular formula. So we'll see an example. So ethanol and methoxymethane. Ethanol and methoxymethane. Notice no. So ethanol, carbon with the 3 of hydrogen, CH, carbon with 2 of hydrogen, here CH2, and OH. Hydrogen, hydrogen, hydrogen. So what is the functional group? Alcohol. So name of the compound, 2-ethane. Ethane, E is replaced by oil, ethanol. We'll be having how many carbon atoms? C2. 3 plus 2, 5 and 6. C2H6O is the molecular formula. C2H6O. Similarly, carbon. Okay, so this one CH3O carbon with CH3 hydrogen, hydrogen, and here hydrogen, oxygen linked to this hydrogen, hydrogen, hydrogen. What is the name of the compound? Methoxy, methoxy methane, OCH3. This is methoxy methane, OCH3. Are you getting? We discussed functional groups. In that functional group, we discussed important functional group. Have you remember? Okay. And especially while we are discussing the functional group, we used the two important compounds of ether and ester. Ether and ester. So R, O, R dash. That is in the form of R, O, R dash. What is this? RO, R dash are called ethers. So methoxymethane. This is also having methoxymethane having two carbon, C2, 3 plus 3, 6 hydrogen and 1 oxygen. Both will be same, no? C6, C2H6O and C2H6O. Okay, but how they are differ? Their their functional group is differ. This is OH, alcohol functional group. This is ether, RO, R dash functional group. Are you getting? Two or more organic compounds will be having same molecular formula but different functional group are called functional isomers. This phenomena is called functional isomerism. Next, last one, metamers or metamerism. Two or more compounds having same molecular formula but different alkyl group on either the side of the functional group of a molecule. So how the group are attached to the function means to the mainstream, So example, carbon with the two of hydrogen. Okay, so carbon with carbon. Okay, how it will be right? Two carbon together. I'll write the formula. Okay, C2H5O C2H5. What is this? Means we'll be writing carbon carbon together. So need not to write. I think you're already familiar with the complete expanded structure. O carbon here CH3 CH3 CH2O CH2 CH3. This is what C2H5. Okay, so this is we call as ethoxyethane. Ethoxyethane. This side or this side, ethoxyethane. So similarly, we have a compound is called CH3O CH3 CH3O CH3O C3H7. So this is methoxypropane C3H7. Okay, is methoxy, is oxygen. CH3O is methoxy. Remaining is 3 carbon, C3H7, that is propane. So methoxypropane. The number of carbon atom. What is the number of carbon atom? Here 2 plus 2, 4, no, C4. Next up, 5 plus 5, H10, O. What about this? CH3O, C3H7, 7 plus 3, 10, 2 carbon, 3 plus 1, 4 carbon, right? And hydrogen, 7 plus 3, 10 and 1, C4H10O, here C4H10O. What is the difference between them? The substituent group, that is what the alkyl group, both alkyl group C2H5 will be the same, and here is CH3, and here this is propane C3H7, and this is CH3. Okay, carbon number 1 with a substituent group. Here carbon number 3 is a substituent group. So these are we call as metamers. We'll see the two important examples. Okay, so first one is C2H5O C2H5 ethoxyethane and methoxypropane. And another important example 3-pentanone and 2-pentanone. Okay, ONE, pentanone, this ketone, no? ONE is a suffix. So here, CH3, CH2, one group. Another side, CH2, CH3, same group, no? If it is differ, this functional group shifts here. It becomes CH3, CH2, CH2, and C double bond O, CH3. So only the ketone, sorry, only the functional group position changes. Here ketone position changes. Okay, here first carbon and second carbon, 1, 2. And if you give numbering from this side or that side, 1, 2, 3 or 1, 2, 3, this carbon will be getting the least number is a 3 itself. So 3, 5 carbon, 1, 2, 3, 4, 5, pentane. E is replaced by the suffix. Okay, that is primary suffix what we consider major. Okay, that is C double bond O or C double bond O or dash, that is ketone. 3 pentanone. So second one, 1 2 3 1 2 3 4 5. Okay, 5 carbons, pentane. 5 carbons, pentane. And E is replaced by ketone, second position. To own, to own or to pentanone. To own or pent to own or to pentanone is the IUPAC system nomenclature. So you'll be learning along with these compounds IUPAC nomenclature.